All right, 2.13, exponential and log equations.
In this unit, we have worked with exponential functions and logarithmic functions while utilizing important properties of each when simplifying expressions and finding equivalent representations. Now we will use those same properties to solve equations and inequalities involving exponential and logarithmic functions. Below are the important properties we have learned related to exponents and logarithms. We will need to be proficient with these properties so that we can use them to solve equations and inequalities involving exponential and logarithmic functions.
Love it. So when we multiply with like bases, what happens to our exponents? They add. When we have a power to a power, we do what with our exponents? We multiply. When it's a negative exponent, where does it go?
To the basement.
To the basement. All right. And then when they multiply for logs, it's really what?
Adding.
Addition, and we can go backwards on that as well. And so when there's subtraction, it's really division. When we have an exponent, it's really a constant multiple, and so that's our power property. And again, how do we solve a log? Log base a of b is equal to c, and we put it in exponential form of a to the c is equal to b. All right, keep going. You're doing great.
If an equation or inequality involves only a single logarithm or only a single exponential function, we can solve by converting between exponential and logarithmic forms.
Step 1.
Isolate the exponential or log expression on one side of the equation.
All right, so we need to get our exponential or logarithm equal to a number. All right, step 2.
Write the equation to the alternate form, exponential to log.
All right, so if it's an exponential, let's put it in log form. If it's in log form, put it in exponential form. All right, keep going.
Solving for the variable if necessary. And then simplify and/or round by answer as directed.
All right, so sometimes we're going to use calculators and round to a fourth decimal. However, today we're just going to give exact forms of them, and so we don't need a calculator today. All right, so here we go. So we got 4 to the power of x minus 2 is equal to 7, so I need to get my exponential equal to a number. So first I do what? Add 2. So now I have 4 to the power of x is equal to 9. And so what form is it in right now? Exponential. So now we're going to put it in log form. And so I'd have log base what? 4 of 9, which is equal to x. Because my a is 4, my c is x, and my b is 9. All right, this next one, the first thing I need to do is do what? Subtract 5. And so now I have 2 to the power of x plus 3 is equal to 21. And so now what do we do? Right now it's in exponential form, so now I need to put it in what form? Log form. And so now I have log base what? 2 of 21 is equal to x plus 3. And so now what do we need? We need to subtract 3. Now, I'm going to write it as x is equal to negative 3 plus log base 2 of 21. And the reason why I do that is because if you look at this form and you say minus 3, unless you put parentheses around your 21, it looks like it's subtracting 3 from 21 and be log base 2 of 18. All right, and so that's why I just put it in front. All right, cool. Let's keep moving. On part C, what do we got to do first? We need to subtract 3. All right, and then what? Divide by negative 4. So negative 10 over negative 4 is what? 5 halves. So now we have 5 halves is equal to e to the x. And so from there, what do we want to do? Convert to log form. And so now I'd have log base what? E. Well, what is log base E? Natural log. And so now I have natural log of what? 5 halves is equal to x. And so there we go. All right, let's keep moving. And so on this one, now we have a logarithm. And so we need to get our log equal to a number first. All right, and so what do we need to do first? We first subtract 4. And so what do we get when we subtract 4? 6. And then what do we want to do?
Change it to exponential.
I don't want to. Divide by 2 first. And so now we're going to divide by 2. And so we get log base 3 of x plus 3 is equal to what? 3. All All right, so we subtracted 4 divided by 2. All right, and so now it's in log form, so now we need to put it in what form? Exponential. And so now I have 3 to the power of 3, which is equal to x plus 3. And so 3 to the power of 3 is 27. And so then I have 27 minus 3, which is 24. So x is equal to 24. All right, let's do it again. And so on this one, what do we do first? Not divide by 2, but subtract 2. All right, and so when we subtract 2, now I'd have a log base 5 of 2x minus 1 is equal to 2. So I got my log equal to a number. So from there, we need to put it in what form? Exponential form. So now I have 5 to the power of 2, which is equal to 2x minus 1. All right, so what is 5 squared? 25. And then what do we do with it? We actually add 1. So what do we get? 26. And then what? Divide by 2. So x is equal to 13. All right, cool. Let's do the next one. And so what do we need to do first on this one? Multiply by 5. We need to multiply by 5. And so now we'd end up with natural log of 2 minus x is equal to 5. And so what is my base here? E. And so now when I raise it to a power of e, it'd be e to the power of 5 is equal to 2 minus x. Now on this one, some people like to subtract 2 and then divide by a -1. I encourage you not to, honestly. I would encourage you to like add x and subtract e to the 5th. Are you still going to arrive to Tampa if you do the other way? Yes. However, try to make your x positive the fastest you can. And that's the way I would say it. So x is equal to 2 minus e to the 5th. And there we go. All right. Max, read loud and proud. You got this.
When working with more than one logarithm, we can use our log properties to simplify expressions before solving the equation or inequality. For equations and inequalities involving multiple logarithms, we will generally simplify to one of these forms. Form 1, log base a of x equals b.
All right, so that's what we did just now. Okay, so we got our log equal to a number. All right, keep going.
Form 2, log base a of x equals log base a of y.
All right, so this is what we call the one-to-one property. And so anyway, when we get those, we can kind of strip our logs a little bit. All right, let's keep going.
If we simplify to form 1, then we can finish solving by converting to exponential form as we did with example 2. If we simplify to form 2, then we can finish solving by setting x equal to y. Important note number 1. In either case, we need to check for extraneous solutions. Using log properties can sometimes lead to solutions that are not in the original equation.
All right, so a lot of the times we're going to back substitute to see if the log can accept it. What can logs not accept? Remember doing our domain stuff? Logs can't be what? Negative. So that's why we set the inside log greater than 0 to find its domain. So if we can do a log, we needed to make sure it's positive. All right, keep going.
Important note number 2. Log of x plus log of y equals log of z does not imply that x plus y equals z. We must use log properties to simplify log of x plus log of y equals log of z. We cannot just cancel out the logs.
All right, so this is the biggest common mistake that I see when teaching this and grading this, honestly. So if we have this, how many logs do I have going on?
3.
We have 3 of them. I can't just get rid of all the logs, okay? The only way we can do that is when we have 2 logs that are equal to each other. All right, so we have log of common bases, the same bases, then we can get rid of the logs. This one, they're not all equal to one another, all right? And so on part A, what do we have to do first to this left side? The addition means what? Multiply. And so then we now have log of what? 3x plus 12, because we multiplied these together 3 times x plus 4, right? Yes. All right, cool. And that's equal to log of 5x minus 2. Now do I have logs being equal? Yes, and they have the same base. What is the base, by the way? 10. And so now we can kind of strip them, and it's technically called the 1-to-1 property. And so now we'd have 3x plus 12 is equal to 5x minus 2. I'm personally going to think about bringing my 3x to the right and then my 2 to the left. And so then I'd end up with what? 14 is equal to 2x, and x would equal 7. Now, this is where we need to back substitute it, and it's not going to take very long. And so this one we can't substitute anywhere. This is log of what? Say 11. Can we do that? Yeah, we can do that. And then this would be log of what? 33. Can we do that? Yeah, so we're good. All right, so let's look at part B now. So on part B, what do we need to do first? Divide. And so now I condense it. So now it's natural log of x plus 1 over 3x minus 5 is equal to natural log of 7. All right, so on this one, now what can we do? Get rid of the natural logs. So we can get rid of the natural logs. And so now I'd end up with this x plus 1 over 3x minus 5 is equal to just 7. So now what do we multiply by? 3x minus 5. And so now I have x plus 1 is equal to how many x's? 21 x's. Whew. And then minus 35. All right. And so now we need to solve for x. So we first subtract x and add 35. So now I have 36 is equal to 20 x's. My gosh. And so then what do? Divide by 20. And so x is equal to 36 over 20. And what would that simplify to? They're both divisible by 4. And so we'd end up with 9/5. All right. All right. And so now if we back substitute, oopsies, that's the eraser. All right, so now when we back substitute, will this be a log of a positive? Yes. Yeah. Yes. And then this one, this would be what? Positive as well. All right. And so we're still good. All right, let's look at part C now. So can I just get rid of log base 3's on this? No. What do we have to do to that left side? We have to multiply. What F word is that? The other F word. FOIL. Okay. When we multiply two binomials together, we FOIL. All right. And so what does it FOIL to? My first is what? X squared. My outers and inners combine to what? Negative 3x, and then positive 2x becomes negative x. And then my outers, or my last, combine to negative 6. And so that's my first step. And so now what can I do? Now I can get rid of my logs. And so now I'm left with x squared minus x minus 6 is equal to 14. And so now I'm going to set this equal to 0 by subtracting 14 over. So now I have x squared minus x minus 20 is equal to 0. Now, what do we like to do to quadratics? We like to factor them. All right. And so let's factor x squared minus x minus 20. And so what does this factor to? X minus 5 and x plus 4. And so now I'm going to set both of them equal to 0. And so I get x is equal to 5 and x equals negative 4. Now, let's substitute 5 back in. So this is log of what? 7. This is log of 2. Are both of those okay? Yeah. Let's substitute in negative 4. This would be log of what? Negative 2. Can we do that? No. And so this is called an extraneous solution. And so that is not the solution we want. So we only have x equals 5 as part of our solution set there. All right. All right, let's do it again. So let's look at part D now. So what do we need to do first? We need to divide. All right. And so now I'd have natural log of x over 3 is equal to 2. Now, on this one, do we strip logs? No. And so this one, what do we do? Right now it's in log form. I need to put it in exponential form. And so now we're going to put it in exponential form. So what's my base? E. So now I have e to the power of 2, which is equal to x over 3. And so then how do I solve for x? I multiply by 3. And so now I have x is equal to 3e squared. All right. Example 4, Max.
Solve the following equations. Check for extraneous solutions when necessary.
All right, let's do it. All right, so what do we need to do first? I need to divide. All right. However, this one also has a what? An exponent going on. So this would be log base 4 of what? X over 8, because it's 2 cubed, which is 8, which is equal to log base 4 of x plus 7. All right. So now what can we do? We can cancel out our logs. All right. And so now we'd end up with what?
X over 8 equals x plus 7.
That was really good. All right. And so now how do we start solving for x? Multiply by 8. And so then we have x is equal to 8x plus 56. All right. And so then I personally like to keep my x's positive. So now I have negative 56 is equal to 7x. And so x will equal negative 56 over 7.
What? Oh, it's 54. 7 goes into 54, not 56.
All right, and so now let's see if it works. Let's see if it works. And so if we back substitute negative 56 over 7 in here, will it work? It won't work, will it? And so what do we know? This is extraneous. This is extraneous, which means what? There's no solution at all. There's no solution on that one. All right, so this one, what's my base on this one? 10. All right, I'm going to show you 2 ways to tamp on this one, and I really don't care afterwards which way we go. All right, and so I'm going to show you the way I wouldn't normally go. And so remember converting 2 into the log base that we wanted to last time when we converted into a common log on the last notes? We're going to do it again. And so this is a log base 10 of something which I want to equal 2. All right. So how could we start this? How do I solve a log? A to the c equals b, right? And so now I'd have 10 to the power of 2, which is equal to b. And so this would be log base 10 of x minus log base 10 of what? 100. Okay? Because 2 is log base 10 of 100. Okay? Those are the same with each other. Does that make sense? All right? And that's equal to this log of x minus 7. All right. And so now, what do we need to do first? Combine our log of x and log of 100. So what's happening here? Division. So now I have log of x over 100 is equal to log of x minus 7. And so now what can we do?
Cancel out logs.
We can cancel them out. And so now I have x over 100 is equal to x minus 7. So what do we get to do? Multiply by 100. And so now I end up with what?
X equals 100x minus 700.
And so then how many x's do I have? 99 x's, which is equal to 700. So x is equal to 700 over 99. Now, is that more or less than 7?
That's more.
It's more. It's more than 7, right? And so when I back substitute this, will this one work? Will this one work? Yes. So we're still good there. All right. Now, I want to show you the way that I personally would think of it. And so on this one, I don't really want to convert to log base 10 of 100. I really wouldn't. And so I would subtract this one and I'd add that one over. All right. And so I would just like rearrange stuff. And so now I'd end up with like log of x minus log of x minus 7 is equal to 2. You see how I just rearranged this? All right. And so that's what I personally would do. And so then on the left side, what do?
Division.
We divide. And so now we'd end up with log of x over x minus 7 is equal to 2. And then how do we solve a log? A to the c equals b. And so now I'd have 10 to the power of 2, which is equal to x over x minus 7. So what is 10 squared? 100. And so now I'm going to multiply 100 with what? X minus 7. And so then I'd end up with 100x minus 700 is equal to x. And now we are the same. All right? And so then we'd end up solving, we'd get x is equal to 700 over 99. Now, I showed you both ways to Tampa. Do I really care which way you go? Not at all. Just go a certain way and don't make math mistakes and you'll get to Tampa. All right? All right.